I'm doing two examples in this video, and it's really important that you watch both of them in their entirety because there's something that I'm going to talk about towards the end of these problems that are really important. So this first one, I want to solve for x. This is a radical equation. And in my previous video about radical equations, I said that you want to think of these two main steps. The first one, isolate your radical. The second one, get rid of the radical so that you can get the x out of there. Now, the problem with this example is I have multiple radicals, and no matter what you do, there's no way to try to isolate one of these radicals because there's two of them. You can try to divide by 5 to the other side, but you're just going to end up with a 1/5 in front of the square root of 35x. So there's nothing to do here. We're just going to have to skip to our next step, which is get rid of those radicals. Now, whenever you have a square root, the opposite of that would be squaring both sides, and that's what we're going to do. And that's how we're going to cancel out our radical. So the left-hand side, all I have is the square root being squared. That means the square root goes away, and I'm left with whatever was inside, which in this case is 35x. The right-hand side, you need to be careful because I have 5 times the square root. Whenever you've got multiple things being multiplied by each other, and there's an exponent on the outside, that exponent has to go to everything inside. So not only canceling out the square root symbol, but also squaring the 5. So really important that you do that. Now, 5 squared is 25, and that's being multiplied by x plus 2. It's still multiplication. And I trust that you know how to solve for x. So if you want to pause the video and do that, go ahead. The first thing you would do is distribute the 25, or that's the first thing that I would do. And then you can solve for x from there. So you should get x equals 5. Now, something I need to point out, going into our second example. When you raise both sides to an even power, so your example started out with square roots or fourth roots or sixth roots or something of an even root, you end up raising both sides to an even power at some point. When this happens, you could end up with an extraneous solution. Now, this isn't the only time you should be checking your work. You should always do that, even if it was an odd power, just so you know if you got it right or not. But what you need to do, especially if it's an even power, is check your work. So I'm going to spare us some time and let you know that x equals 5 does work. What you would do is replace both x's in the original equation with 5 and see if the left-hand side is equal to the right-hand side. And I'm letting you know that it is true. So x equals 5 is the correct answer. But I will demonstrate how to actually check your answers in this next one. So remembering your steps, you want to isolate the radical, and then you want to get rid of said radical. This time, we've got the square root of x plus 18 with a plus 2 added to it. That does not equal x plus 20. Please do not do that. And this is all equal to x. So if I want to get the square root by itself, the first thing I'm going to do is subtract 2. And now we have x minus 2 on the other side. Now that the radical is alone, I can get rid of it by raising it to whatever power matches its root. Since the square root technically has a root of 2, I'm going to square both sides. Now, what I'm about to tell you is so important because I see it all the time, and I need you to write this down and make a note of it and never do it again. On the left, square root and squared cancel. That's fine. You better be careful with the right-hand side, and I need you to go back in your brain and think about what does an exponent of 2 actually mean. So when you simplify the right-hand side, you are not just squaring x and squaring 2. Remember, the exponent of 2 means you have 2 of them. Now, I know you're probably thinking, she did this in the first one. I did not. The first one was multiplication. It was 5 times the square root. This one is not multiplication. It's x minus 2. So I can't just distribute the exponent like that. It doesn't work that way. You cannot write this as x squared minus 4 Or if you wrote it as x squared plus 4, that's also wrong. So please don't do this. Pause the video and make a huge note of this so you never do it again. When you have something squared or something cubed or something to the fourth, whatever, that's how many times you are multiplying it by itself. So x minus 2 squared is x minus 2 times x minus 2, which means we must FOIL. Please make sure you do this correctly. So FOILing it out and then combining the middle terms, we end up with x plus 18 on the left still, and x squared minus 4x plus 4. Now, if you know what you're doing, I encourage you to pause the video and try to solve for x yourself. Whenever you have a quadratic, so something squared, remember, you want to move everything to one side so that you can factor, or at least try to factor. Sometimes it's just not factorable. So if that gave you a hint, pause the video and try it yourself. Otherwise, I'm going to keep going. What you do is move the x and move the 18 over. So subtracting x, subtracting 18. We end up with x squared minus 5x minus 14 on the other side. And then since we can factor, we're going to look for two numbers that multiply to negative 14 and add to negative 5. Those two numbers would be negative 7 and positive 2. And then you set those factors equal to 0 and you solve for x. So we end up with two solutions here, x equals 7 and x equals negative 2. Now, this is what I pointed out earlier in the video. I squared both sides, which is an even power. So it's very important that you check your work. It's always important to check your work, but especially here. So what you're doing is you're taking 7 and you're taking negative 2 and you're plugging them back into the original equation, not the one that was squared, the original, before I did anything to it. So I'm going to replace every single x with 7, and I'm going to replace every single x with negative 2, and I'm going to see if the left-hand side is actually equal to the right-hand side. So what I would love is if you pause the video and try that yourself. We are plugging 7 and negative 2 in. Just leave the equation as is and simplify whatever you have on the left and see if it equals the right. So here is my work when I checked. When you plug in 7, you eventually end up doing 5 plus 2, which is equal to 7. But when you plug in negative 2, you end up doing 4 plus 2, and that is definitely not equal to negative 2. So we have a conclusion here that both of these are not the answer. We would say that 7 is the solution, but we would have to label negative 2 as the extraneous solution. So if I were to ask you what's the answer to this, you would just say 7. Unless you specifically told me that negative 2 was extraneous, you would be incorrect if you told me that both of these were answers and both of these were solutions to this equation.